Hello and welcome back to Outer Space for our second lesson in our Introduction to Calculus, differential calculus that is. So when you were last with us, we were working on finding the derivatives of f of x equals x squared and f of x equals x cubed. And our solutions were
f prime of x equals 2x.
And we also had
f prime of x equals 3x squared. What are you doing over there? What are you doing over there?
Okay, goodbye, guys. That's what we had for those. Well, here comes a couple other problems. And what I'd like you to do is to work on trying to solve these. Actually, we're not going to solve these. What I'm going to do is I'm going to give you the question, and then I'm going to give you the answer. And I'm going to ask you to look for a pattern in how this solution to this problem works. And then as a companion problem, if you can do the algebra to make sense of that, please work that stuff up and submit it, okay? So the first one is going to be, we're going to differentiate. Now, by the way, what I'm going to do, I'm going to give you y equals. And as your answer, you can write y prime equals. So we had f of x and f prime of x. There's another notation too. We can use y and then y prime, and everyone would know that y prime is the derivative, what's called the first derivative. All right, so here we go. The first one is 2x cubed plus 4x minus 6. That's y equals 2x cubed plus 4x minus 6. One more time. Y equals 2x cubed plus 4x minus 6. And the derivative of this is
the derivative of y equals 2x cubed plus 4x minus 6 is y prime is equal to 6x squared plus 4.
That's my friend Piotr the cosmonaut. Let's see what else we got. The other one is 3x to the fourth minus 2x cubed plus x squared plus 3. So the question is, what is the derivative of y equals 3x to the fourth minus 2x cubed plus x squared plus 3? That problem again, y equals 3x to the fourth minus 2x cubed plus x squared plus 3. And the derivative is?
The derivative of that one is y prime is equal to 12x cubed minus 6x squared plus 2x.
Well done. Okay, goodbye. All right. So that was that work. Here's another thing to do. So that was problem number one, basically, was get these two derivatives, or look for what patterns you see in them. The next question is going to be, I want you to grab a calculator if you have one, and set your window to be from x equals -7 to +7, -7 to +7, and set your the y from -2 to +2. All right, make sure you're in radian mode. And the first question is going to be to do y equals sine x, graph it, and watch what happens with that lovely thing. The next thing is to, using the same window and all that, change the function so that you have y equals cosine x, again in radians, and you'll see something happen. All right. Then if you want, you can put sine x and cosine x together and watch it graph one and then the other and see what happens. All right. Now, we are talking about the idea of derivatives. And so what I'd like you to do is, after seeing that, write up a sentence or two explaining, why did I have you just take a look at sine and cosine? And that brings us to our third question. Our third question now is that about a very interesting kind of function. It's another function family. So we've looked at linear functions which have pretty boring derivatives, and just straight, a straight line just has a constant slope, so this derivative is just a flat line. A function like a parabola or a cubic or a quartic or a quintic is going to have a derivative that is going to be some other kind of polynomial, and whatever the degree of the function is, the degree of the derivative is going to be one less. You've probably noticed that already. though you've got other patterns to notice in those polynomials. There are also trigonometric functions which have derivatives, and those are interesting. Well, then comes the question of, is there a function that when you find the derivative, it is the original function? Seeing all these other things, the original function is one thing, and the derivative is something else. But what if the derivative is the original function? Now you could give a boring answer to this, saying the function y equals 0. Because 0 is a constant, that's a horizontal line, there's no change in its slope, and so the change in slope is 0, and so the derivative is 0. So the function is the x-axis, and the derivative is the x-axis. Whoop-de-doo. Super boring. But there's a non-boring answer to this question, and that would be a function that, when the value of the function is low, the slope of the function is low. The function is very flat. And when the value of the function is high, the slope of the function would be very high. Well, so you get an idea that you go from very flat to very high, and as it turns out, that happens as x is increasing, and so you have an increasing function getting more and more and more steep. Now you might remember last video we talked about, or a couple of videos ago, we talked about 2 to the x taking off. There is a function that does that, but 2 to the x is not its own derivative. You can prove that a couple of different ways. But anyway, it turns out there is a function, and it's a pretty simple function. It doesn't have it has a y-intercept, but the y-intercept is at 1. It has a point 0, 1, because anything to the 0 power equals 1. So that's in there. So we've got a slope of 1 at that point. Well, there is a number to use as a base for this. And it's not 2, and it's not 3, and it's not pi. It's something. This is something to the x. The question for you is, what is the base of the exponential function that is its own derivative? What I'd like you to do with that one is take a guess. Alrighty? Then look it up. So take a guess, write down what the guess is as part of your assignment. Then look it up, and then write about what you guessed and what you found. And that is the assignment, those 3 questions. Let's find those derivatives, or rather, what patterns do you see in those derivatives? What do you see in the patterns of sine and cosine? And what is the function that is its own derivative? Take a guess, it's an exponential. Take a guess first, then look it up, and write something up about how your guess compared to what you found. Thank you very much. Have a fantastic Wednesday and going into Thursday. All right. Hey, here's a question also. If you would like a buddy to bring along, I've got some students that aren't getting a whole lot done, and if you want to say, hey, give me some names and I'll contact them and stuff, drop me a line in your assignment. Like, hey, I'd be happy to help somebody else out. And that would be fantastic. So I'd like to bestow bonus credit on you for that. I think that would be really worthwhile, because those of you that are doing this work are doing a fantastic job. And I think more people can do a fantastic job. I think you could help. Thanks so much. Have a great, great day.